All right, here's your homework for area of a triangle. So you have a side angle side. Oh no, this is first. This side is actually practicing the law of sines and cosines. So if I want to find the side JL, recognize what type of triangle it is. It is side angle side. So I'm going to use the law of cosines to find JL. That's what I need to do first. So I'll say it's X. And the law of cosines, huge square root sign. And then pick a side, square it, plus pick the other side, square it. Order doesn't matter. Minus 2, use the same 2, order doesn't matter. And then the cosine of the angle in between them. And what do you get? Let me use my calculator. .116. To find angle J using law of cosines, it's going to be inverse cosine, big fraction line. So opposite of J is 13. So it's 13 squared, subtract 21 squared, subtract 31.116 squared. That's the side we just came up with. And then negative 2, 21, 31.116. All right, so let's type it in. Double check, make sure I typed it in right. I get angle J to be 18.379 or 380. To find the last angle, you just subtract 180. So I'm going to go plus 131, subtract 180. What's left is 30.620. So again, the last one, I just went 180, take away 21, take away 18.380. Did I say 21? I meant 180, take away 131, take away 18. All right, number 2. This is angle side. So this is going to be the law of sines. So the first thing I'm going to do is angle F is easy to find. So 180 take away. So 180 subtract 83, subtract 66, and this angle is 31 degrees. Then to find E to F, I'm going to call that X. So sine 83 over 31, and then it's sine 66 over X. To get X by itself, it's 31 times sine 66 divided by sine 83, and then .533. That's E to F. The other one, I'll do it up here in the corner. We start with sine 83 over 31. I'll call this Y. So opposite of Y is that angle I found, 31. And then to get Y by itself, it's 31 sine 31 over sine 83. and I get that side to be 16.086. And these are yards. All right, look at number 3. You try it. All right, so which law do you have to use now that you've tried? So side, side, side is going to be the law of cosines. So to find an angle, pick an angle. So PQR, why not? Alphabetical, P. So if I want to find angle P, then it's inverse cosine. What side is opposite? It's 27. And then the other ones, the order does not matter. And then it's -2, and then again 24 and 45. All right, use your calculator. And you get 29.926. All right, now I can't use basic triangle properties yet, so I got to find another angle. So I'm going to, I'll go Q. So see if you can set up Q, and then I'll set it up. So opposite of Q is 45. And then we have 24 and 27. -2, 24 and 27. And now use your calculator. Make sure I set it up correctly. And it's 123.749 degrees. Now this last one, I just need to go 180, subtract that. So 180 subtract 29.926, subtract 123.749. And that last angle I get is 26.325. All right, let's read a story. Jason and Allison are hiking in the woods when they spot a rare owl in a tree. Jason stops and measures an angle of elevation to be this. At the same time, Allison's standing 48 feet closer to the tree, measuring an angle of elevation of this to the owl. If Jason and Allison are the same height, their eyes are 5 feet from the ground. Find the height of the owl in a tree. Okay, so I have a tree, and in that tree is an owl. There's my owl. Somewhere here, Jason spotted the angle of elevation to the owl. Now, I need to draw a horizontal line to help me out with that. And this is that angle there is 22 point, and then it gives you 8 minutes and 6 seconds. Kind of silliness, right? 8 minutes and 6 seconds. But I'm going to change it all to seconds. So 8 minutes is equal to 8 times 60, right? 480 seconds. And then 6 more seconds, add 6 sets, so it's 486 seconds divided by 3,600 seconds in an hour. So I get 0.135. So that angle there is 22.135. All right, now Allison's a little closer, but the same height. So her angle to the same owl is 30 degrees and then 40 minutes and 30 seconds. So 40 minutes and 30 seconds, that's 40 and a half minutes divided by 60. So you get 0.675. All right, so it's 30.675. Our goal is to find this. I'm going to label it X, which is find the height of the owl in the tree, right? That's my goal. That height right there. And to that one I have to add 5, right, to it? Because it's 5. This right here is 5 feet. So whatever I do, I'm going to add 5 feet to whatever that answer is. So now the question is, how do I get there? So I want you to recognize there are 2 right triangles and an obtuse triangle in here. So I'm going to label this Y. This is the hypotenuse, but this side right here is shared by 2 triangles. It's shared by a small right triangle, and it's shared by the obtuse angle here that I see. So we're going to do some math here to understand. There is a supplementary angle here. So on one side is 30.675. If I go 180 subtract 30.675, then the other angle, the one inside the obtuse triangle, is 149.325. Now I need that angle because now I have 2 angles that I'm looking at. Now we also know the distance between Allison and Jason is 48 feet. So now I have an angle, a side, and an angle, and I want to solve for y. So that's the law of sines. So I'm going to go sine. Now what do I know? So I know 48 feet, but I need to know this angle up here to use 48 feet. Well, now we have enough information to do that. So I'm going to go 180 subtract 149.325 subtract 22.135. And that little angle up there is 8.540 or 8.54. But I need that little angle because that's the angle opposite of 48. So I want to find this long side, which is also the hypotenuse of the right triangle on the left. The angle opposite of that is 22.135. And I'm going to solve for y. So to get y by itself, it's 48 times sine 22.135 divided by sine 8.54. So that's what you put in your calculator. Doing the same thing. So 121. So y is equal to 121.791 feet. All right, so now I know y. Now I have a right triangle I can work with. So my goal is to find the missing side of a right triangle. So again, I'm going to use this angle that's inside the right triangle, the small right triangle. And I know the hypotenuse is y. So it's opposite over hypotenuse. So it's going to be the sine of that angle, 30.675, is equal to, what's opposite of it, x, and what's the hypotenuse, y, but I know it's 121.791. To get x by itself, you just multiply. So it's 121.791 times sine 30.675. And you get 62.134. And then to that answer, you have to add 5 because it's not yet to the ground, how high the owl is. And so your end answer is 67.134 feet. So, how tall is the owl? And the answer is the height of the owl on the tree is 67.134. Using the law of sines and SOHCAHTOA, right triangle trigonometry, and adding the 5 feet from the eyeballs to the ground, you get your answer. Good job. Turn the page. Another story. A drone is flying over a college campus. The drone spots the cafeteria on the west end of the campus at 27 degrees. And the sports complex on the east end at 34 degrees. Both are angle of depression. So I need to draw a drone. I don't really know how to draw a drone. Is that like a drone? Like a UFO, right? And so it says on the west, that would be the left, is the cafeteria. So on the left is here, the cafeteria. And so the angle of depression is 27. And then on the right is the sports complex. And that angle of depression is 34. And then it says, if the cafeteria and sports complex are separated by a straight road, so this length right here is 2.3 miles. How high is the drone, which is this part right here? How high is this drone? So that's my goal right there, is to figure out how high it is using that information. So how are we going to do that? So the only thing I know is 2.3. So if you think through, what's the angle opposite of that? 2.3. Notice that the angles of depression and what's inside the triangle, all of them together make 180. They make one line. So if I go 180, take away 27, take away 34, what's left is the angle inside that triangle. So 180, take away 27, take away 34, and you get 119. That's this whole angle right here, 119. So I'm going to go sine 119 over 2.3, and now I have a choice to make. So the choice to make is, I can either pick one side or the other side to use from here. So I'm going to make this choice. I'm going to solve for this side. That's the distance from the drone to the sports complex. But that means I need to know the angle here. Now, in this case, in order to do that, we are going to use parallel lines. So we have parallel lines that make a Z. This is 27 degrees down here using the angle of depression up there. See that Z pattern? Alternate interior angles. So the sine of 27 and what's opposite of it is over x. So you get x by itself, it's 2.3 times sine 27 divided by sine 119. So let me do that. And I get 1.194 miles. Now that I know this, now I can solve what I'm looking for. So now I'm going to fill this in and see there's a right triangle on the right side. And for this right triangle, again I'm going to do the Z pattern. I know this angle in here for the right triangle on the right side is 34 degrees. I know the hypotenuse, and what I'm solving for, I'm going to call it H, is that height right there. So from 34 degrees, opposite and hypotenuse, that's sine. So the sine of 34 is equal to opposite over hypotenuse. And we just said the hypotenuse is 1.194. So to get h by itself, we multiply and then use our calculator. So 1.194 times the sine of 34, and you get 0.668 miles. So how high is that drone? And the answer is 0.668 miles. All right, number 6. 2 bikes left at 11:30 a.m. for a ride. Rider A traveled at a constant rate at 12 miles per hour, bearing north 47 degrees east. We'll talk about that. Stopping at 1:30 p.m. Rider B traveled until 3 p.m., biking at a constant rate at 9 miles per hour, and went south 62 degrees east. Determine the distance between the 2 bikes. Okay, let's just do this. Let's say this is a compass. This goes north, and this goes south. The first bike, regardless of the speed and time, we're just going to worry about the angle first, is going north 47 degrees east. So first you're talking north, and then how many degrees to the east? So we need to have some point here in the middle between north and south, and know that we're going north and then 47 degrees east. So I'm going to draw this line and know that this angle here is 47 degrees. So north and then 47 degrees east. Just so that I know you know this. North, south, east, west. But just in case you need a little reminder where these things are located. The second one, they left at the same point but went south 62 degrees east. So that means that angle there is 62 degrees. So south and then 62 degrees east. So at least we have a little diagram to begin with. Next, now we're going to read about, and our goal is this, right? The distance between them. So that's our ultimate goal right there. Before I move forward, I can even find the angle inside the triangle, knowing that makes a line, 180. So I can go 180, subtract 47, subtract 62. So this angle in here is 101 because it makes, what did I use? I typed in wrong. So try it again. 180, subtract 47, subtract 62. I don't know what I did. 71. Jeez, didn't look like 101 either. So this angle in here is 71 degrees. Okay, moving on. Now the time and everything else. So what time did they start at? 11:30 a.m. And rider A is going 12 miles an hour and stopped at 1:30. So let's first of all figure out the time. So how much time has gone by from 11:30 to 1:30? and that's exactly 2 hours. And then how fast is he going? Well, he's going 12 miles an hour. So we're going to use this formula. Distance is equal to rate times time. So his rate is 12, and for 2 hours, that means how far did he go is 24 miles. So we're going to label 24 miles here for A. The second one didn't stop until 3. So we have 11:30 a.m. to 3 p.m. Well, that would be how many hours? 3.5 hours, right? So using the same type of formula here, the rate he went was 9 miles per hour, and then 3.5. How far did you go in 3.5 hours times 9? $31.5. So this one here is 31.5. Now we can solve for what we're looking for. So what information do we have? Which law do we have to use to solve for x? So we know 2 of the sides, and we know an angle in between. So it's side, angle, side. So it's the law of cosines. So the big square root, and we start with any of the sides, so 31.5 squared plus 24 squared minus 2 times 31.5 times 24 times the cosine of the angle in between them, and then use your calculator. So I'll do that too. You can always press pause if I'm going too quick. You can also rewind. Close it, and you get 32.802. So how far are they apart? Almost 33 miles. All right, number 7. Now area questions. Can you find the area of this triangle? Side, angle, side. Super easy. 1/2, and then it's the side, 17 and 30, times the sine of the angle in between them. Done. So 0.5 times 17 times 30 times the sine of 114. 232 point, they say round to the nearest tenth, whatever. I'm going to go to 3 decimals. Good habit. 954. And that's kilometers squared because it's area. Number 8, side, angle, side. So the area is 1/2, 17. Oh, and I don't know that side, right? So in order for me to find the area of this triangle, I need side, angle, side. So which side do I need to know? And I don't have a choice. I need to this one, so it's in between, right? Side, angle, side. So I need to know this angle here. So I'm going to go 180, take away 61, take away 80, and I get 39. So it's sine, and I got to use 80 degrees. So sine 80 over 17, sine 39 over x. So we're going to go 17 times sine 39 divided by sine 80. So that side is 10.864. Now I can do this. So now this is 10.864, and then the sine of the angle in between them, which is 61. So there we go. Oh, make sure I type it in right. 0.5. I'm using 0.5 when I use the calculator. So 0.5 times 17 times 10.864 times the sine of 61. And the approximate area is 80.766 feet squared. All right, number 9. In triangle ABC, AB is 26, angle A is 127, and angle B is 41. Find the area of that triangle. So again, I need side, angle, side. So I can pick either way to do this, but I need to know this side, or I need to know this side to go side, angle, side. So make a choice. So I'm going to pick this side, so I have side, angle, side. To find that side, I'm going to go sine, and I need to know that angle in order to do it. So let's go 180, take away 127, take away 41. That's 12. So sine 12 over 26, and then sine 41 over x. So to get x by itself, 26 times sine 41 divided by sine 12. And I get about 82.042. So that's the missing side that I found. Then I have side, angle, side. So we have side, angle, side. So I'm going to go, area is 1/2 26 times 82.042 times the sine of the angle in between them, which is 41. No, which is 127. I don't know, this is not, it's side, angle, side. Haha. So it's 127. So 1/2 times 26 times 82.042 times the sine of 127. And I get 851.782, and this is going to be miles squared. All right, number 10. If a triangular garden has 3 sides, use Heron's formula to find its area. So we have 8 feet. Now, I got to change this. So 9 feet, 3 inches. So either you're going to change it to a decimal, or it's all going to be in inches. So let's say I want to change it to a decimal. How many inches are in a foot? So 3 out of 12 is what decimal? So 3/12 is 9.25. It's a quarter. And then 9 inches is how much out of a foot? So 9 divided by 12. That's 3/4. So that's 0.75. So I have to at least change it to 1 unit. So now it's all in feet using a decimal. So there's 2 steps to Heron's formula. One step is you have to solve for S, or a number that when you add them all up, divide by 2. So it's 8 plus 9.25 plus 13.75, and that's all divided by 2. Be careful that you add this up, press enter, and get an answer, and then divide by 2 for order of operations. We have to add it all first, get an answer, divide by 2, then put it down. I'm going to write it as a decimal, so it's 15.5. Then the area is one big square root sign, and we start with 15.5. And then you subtract 15.5 from each side one at a time. 8, then 15.5 subtract 9.25, and then 15.5 subtract 13.75. So be careful how you type that in your calculator. So square root 15.5 parentheses 15.5 take away 8, 15.5 take away 9.25, 15.5 take away 13.75, then close it twice, and then get your answer. So it's about 35.658 feet squared. All right, good job doing your homework. Law of sines, cosines, even some right triangle trigonometry, area of a triangle. Good job doing your homework. Mr. G Math, over and out.